One of my goals with 3D printing has been to explore different materials so that I can learn their properties, how to print with them, and share that information back with you. Well, it has been over 6 months since we have covered a new type of filament, which is far too long. PVA, or polyvinyl alcohol, is the most common water-soluble support material used in traditional FDM 3D printing. This material is used to print models that would otherwise be impossible due to their complex geometries, as well as eliminate the need to have a gap between your model and supports. In today's video, we will be diving into PVA. We will cover the properties of the material, what is required to print with it both on the hardware and slicer side, and of course we will do some 3D printing. We will be using Polymaker's PVA called PolyDissolve S1. However, the information in this video will be applicable to other PVAs as well. So with all that being said, and without further ado, let's get right into today's video. Massive thanks to MicroSwiss for sponsoring today's video. MicroSwiss manufactures hot ends, extruders, and nozzles for over 30 different 3D printer models and is constantly expanding. I've been running their upgrades on a wide range of Creality printers for over 2 years now and have printed everything from standard PLA to carbon fiber nylon with them. I love that they're based in the US and that all their products are machined in-house. This helps them to maintain the extremely high level of quality that their customers have grown to expect. Another huge perk is that their upgrades are made for specific machines, making them drop-in replacements in most instances. This helps expedite the upgrade process and allows you to get up and running again quickly. Links will be in the description to find out more about the various upgrades they offer or to pick up your own. First discovered in Germany in 1912, PVA is commonly used in liquid glues, glue sticks, as well as other forms of adhesives. PVA is quite flexible, translucent white or cream in color, and odorless. One of its most unique properties and the quality that makes it attractive for 3D printing is that it is highly soluble in water. This allows us to use it as a support material that we can then submerge in water to dissolve away the PVA, leaving us with just our finished part. The majority of users I've talked to over the years have primarily used PVA along with PLA, and that's definitely where I would at least recommend starting. I've also heard of others using it with TPU as well as nylon with varying degrees of success. Jumping into the printing requirements, PVA is extremely hygroscopic. It's actually the most hygroscopic material I've ever used, beating out even nylons. Some time ago, I posted a video of some PVA that I had that, while it was being extruded, was steaming and popping. Due to this, the first thing that you're going to need is a filament dryer. PVA prints at fairly low temps, and I typically will dry it between 45 and 50 Celsius for at least 4 hours prior to printing. I don't recommend going above 50 Celsius when drying out of fear that you might actually melt the PVA while it's on the spool, which would not be good. Part of it will depend on the humidity where you live, but if at all possible with PVA, I recommend printing directly from your active dryer into the 3D printer so that the entire time it is printing, it is drying out the material. You'll want a dual extrusion 3D printer that has 2 different extruders and 2 different hot ends. I don't recommend things like a 2-in-1 mixing extruder or something like the MMU2 or even the Mosaic palette. PVA can be fairly costly, and from my own personal experience, it's really not worth the headache to use any of those setups with PVA. I'm going to be using the Sovol SV04, which uses an IDEX or independent dual extrusion system. For the extruder, you can get away with a Bowden setup if you print at even slower speeds, but I really recommend and prefer having a direct drive extruder with a fairly constrained filament path. PVA is not quite elastic like NinjaFlex, but handling the material, it definitely shares some similarities with something like 95 to 98A shore hardness TPUs. As for the hot end, you do not need to have an all-metal hot end. Polymaker recommends printing between 215 to 225 Celsius for their PolyDissolve, and I've seen other manufacturers recommend even lower temperatures. My experience with PVA has been exclusively with PLA, and I set them to be the same temperature, which is between 215 to 220 Celsius depending on the printer. PVA is not abrasive, so any nozzle, including a stock brass nozzle, will be absolutely fine. As far as adhesion goes, PVA isn't really all that tough. I've used BuildTac glass with glue stick, and for this, I'm using the Wham Bam powder-coated PEI flex plate system. Many glue sticks, including Elmer's, contain at least some degree of PVA, so if you are having any issues with adhesion, putting down a light coat of glue stick will really help for the PVA to bite with your build surface. A heated bed is not a requirement, but in 2022, most all 3D printers come with heated beds now, and so I just set it to 60 Celsius, the same as what I used for PLA. For our test model, I'm going to be using the Gyro, the Dodo model, which is my absolute favorite for showing what PVA is capable of. This model was created by Vertox for Ultimaker to show off their dual extrusion platform, but is available for all, and I will have the link to this model in the description of this video. The model has very complex geometries that would be impossible to print without the use of dissolvable support materials. Jumping into the slicer, I'm going to be using the Sovol slicer since it's set up for the SVO4, which is just a skinned version of Cura. Just about all of my dual extrusion 3D printing experience has been in Cura because that is the primary slicer that I used for a lot of years. Prusa Slicer does have dual extrusion capabilities as well, and some of this will translate over. First, you will of course need to have your printer profile set up for 2 extruders. You can check this under Manage Printers, Machine Settings, under Number of Extruders. In the top toolbar, you can set the material profile for each extruder. Because the settings are so similar to each other when printing PLA and PVA, either leaving them both as PLA or setting one to PLA and one to PVA will also work. For this example, I decided to leave both of them as generic PLA. Starting with extruder 1, which is our PLA extruder, I set the layer height to 0.2, top, bottom, and shells to 4, and the infill to 20% grid. Those settings are just personal preference and are sort of my standard, but depending on the model you're printing and what exactly your application is for the finished part, you can adjust those to your specific needs. For temps, I set the hot end to 215 Celsius and the bed to 60 C. I highly recommend turning on Z-hopping. PVA is known to print a bit messy, and having even a slight Z-hop of double your layer height can really help to prevent a nozzle from snagging it. We covered Z-hopping in detail in a recent video that I will have linked in the card above. For speeds, we are not going above 60 millimeters per second. It's not that you can't print PVA and PLA faster than that, but my goal of these videos is always to get you up and running successfully. After you've had a couple of successful prints, feel free to scale these settings accordingly. If support speed is not enabled in your Cura by default, go to Manage Setting Visibility, search for it, and enable it by clicking the checkbox. For the support speed, I'm going to set it to an even slower 40 millimeters a second as a starting point. Under Support, click Generate Support and change the support extruder to the right extruder to use PVA instead of PLA for your supports. For this model, we will set it to everywhere, and I always like to prime my hot end with a couple of skirt lines prior to printing. Now we will click on tab 2 for our PVA extruder, and we will mirror everything that we changed for the first extruder. I do drop the print speeds down to 40 millimeters a second for this tool head, but since we're only using it in this case as the support material, you really only need to change the support speed. I also slightly dropped down the retraction distance. PVA will have some degree of stringing, but too much retraction can cause issues like with TPUs that can lead to things like clogging. Cooling at 100% for the PVA is fine, just like you would use for PLA. We're now ready to slice up our model, transfer it to our SD card, and send it off to the printer. With these settings, it is a long print at just over a day. Both the slow printing speeds and tool heads heating and cooling between changes will contribute to this. I watched the beginning of the print go down and then checked on it periodically throughout the day. As long as the PVA hot end and extruder has not clogged, don't worry too much about it looking a bit messy. Again, PVA is known to just look a little bit like a mess while it is printing. At just over a day, the print completed, and I was really excited to pop it off of the build plate. Our next step is to dissolve the PVA. For this, I purchased an inexpensive acrylic tub that I filled with lukewarm water before submerging the part. I set up a time lapse that I had planned on running overnight, but within 2 hours, the majority of the PVA had completely dissolved away from the part. This is really impressive and has not been the case with a lot of other PVAs I've used in the past. To speed up the process of dissolving PVA, I recommend using lukewarm water, the biggest tub that you can realistically use, so that way the PVA doesn't sort of dilute the little bit of water quickly, and either manually agitating the part every once in a while, or if at all possible, if you're going to be printing with a lot of PVA consistently, getting some kind of a setup where you maybe have a pump that's helping to cycle the water around can also help to expedite the process of the PVA dissolving away. The end result is a really epic print. The Sovol has been purging a little bit of extra material on each layer change, which unfortunately means in this case that it does not spin freely like it's supposed to. However, I did print this earlier in the year and I will have a video overlay so you can see it, but typically this thing, all of the different shapes inside of here will spin independently, and it's just a really, really awesome model. One other great way to use PVA is as an interface layer. This will allow you to use PLA or whatever other material you're printing with as your support material, until it's getting to the couple of layers before it's going to touch your part, which is called the interface layer, and you can switch over to PVA then. This will use up much less of the PVA and will allow you to set your support gap to 0. When the print completes, it's much easier to tear off the supports using the PVA as the interface layer, and you can of course drop it in water, which will help to soften it and make the removal process even easier. In Cura, a few settings may not be enabled by default. Similar to what we did for support speed, go under Manage Setting Visibility and enable Support Interface Extruder, Z Distance, and enable Support Interface. Then check to enable the support interface, set the support interface extruder to the PVA extruder, and set the Z distance to 0. This works great for character models or really any model that will be difficult to remove the supports from. PVA requires slower print settings, some post-processing, and is definitely more expensive than other materials, especially PLA, so it wouldn't be something I would choose to print with just for fun. However, for complex models not designed for additive manufacturing, parts with geometries that would just be impossible to print, or to be able to again set your support gap to 0, it is a very cool material and awesome to have in your arsenal. If of course you have a dual extrusion 3D printer that's capable of printing with it. And that has been 3D printing with PVA. I hope that you enjoyed this video and that you have a much better understanding of what PVA is, how to print with it, and maybe some of the scenarios that would make sense to use it. Let me know in the comments down below if you've printed with PVA and what your experience has been like. I'm also really curious to hear from anybody that's printed with it with a material other than PLA and what your results were like. On that note, don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. And if you do want to support the channel furthermore, I'll have links down below in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot, and I look forward to seeing you guys in my next video. Peace, guys!